In this chapter 5, we're looking at different ways to compare two numbers. Well, we're always making a fraction out of the two numbers. In a ratio, we're comparing two numbers, two quantities that are measured in the same units. So, for example, a ratio of 6 inches to 15 inches. Okay, so comparing 16 inches to 15 inches, so we make the fraction. And really, yeah, the units don't matter here. It's the same units, so we get the same ratio, just 16 to 15. And of course, this simplifies, cancel 3's, so it's 2 over 5, so the ratio is 2 to 5, 2:5. All right, so if it's the same units, then it's the units cancel. We get the same ratio. If it was 6 miles to 15 miles, the ratio would be 2 to 5. In this section, we look at rates. So what is a rate? Well, just the difference is in a rate, we're comparing two quantities that are measured in different units. For example, if Anna earns $1,800 for 3 weeks of work, we can compare these two numbers with a rate. Okay, so the first number was 1,800. The units were dollars. And the second number was 3 weeks. Yeah, so now the units don't cancel. The basic fraction here is 1,800 over 3, but it's measuring a rate. It's measuring the dollars she was paid per week. But the fraction does simplify, cancel 3's. That's 600 over 1, or just $600 per week. Okay, and that makes sense, right? She was getting paid $600 per week. So for 3 weeks, that's $1,800. If Anna keeps getting paid at the same rate and works for another 5 weeks, then she'll make, well, 5 times 600, that's $3,000. And now we can connect this with what we were doing earlier in the chapter. So we're really getting a proportion. All right, so the point is, why are these equal? Well, she's getting paid at the same rate, so her weekly pay is the same. So these quantities are equal. Both of these are equal. Both of these simplify to $600 per week. Okay, it's just the difference is now we have the top number measures dollars, the bottom number measures weeks. And so unlike a ratio, that we don't have the same units, so we have to keep track of dollars per week. Yeah, this Latin word per just means you're dividing. So dollars divided by weeks. But just ignoring the units, then it's just a regular proportion. And so 1,800 over 3 equals 3,000 over 5. So this is a true proportion. You could check the cross products are equal, or easier, if you simplify both of these, you get 600. Okay, example 1. Suppose your new electric car charges at a constant rate. All right, so I updated this example from miles per gallon of gas. If you can drive 225 miles after 5 hours of charging, how far can you drive on an 8-hour charge? All right, so you're plugging in your electric car. If you plug it in for 5 hours, that gets you can drive 225 miles. If you plug it in for 8 hours, you're going to be able to get further. We're assuming it charges at a constant rate. So how much further can you go on 8 hours? All right, so the rate here, we're looking at miles you can drive per hour of charge. Okay, so it's miles per hour of charge. Okay, so for the first case, for the 5-hour charge, that was 225 miles over 5 hours of charging. In the second case, so we want to set it up the same way. So we don't know the number of miles we can drive, but on the bottom, it's instead of 5 hours, it's 8 hours. Okay, so this question mark, that's the missing number that we're trying to find. So usually in these questions, let x be that missing number. In this case, it's the unknown range. It'll be measured in miles. All right, so this is how we set it up. So these two rates have to be equal. It's the same car, the same charging system. So 225 miles from a 5-hour charge, well, that rate is going to be equal to x miles for an 8-hour charge. We're looking for x. And yeah, just notice if miles are on the top here, then miles have to be on the top here, hours on the bottom, hours on the bottom. So these pieces have to match. Okay, so now we're back to solving a proportion like we were doing in the last 2 sections. Remember, there are 3 steps. So first step, see if you can simplify the fraction on one side. Yeah, there's a common factor of 5 here, so we can cancel 5s to get an easier proportion. That was step A. Step B, set the cross products equal. Okay, so like we've been doing, for this proportion to be true, then 45 times 8 has to equal 1 times x. All right, this is easy. So 1 times x is just x. So multiply this, we get 360. So x. So 360 equals x, or x equals 360. Again, yeah, usually this is step C if If this was, say, 3x equals 360, then divide both sides by x. Divide both sides by 3 to get x on its own. All right, so we've got x equals 360. Yeah, don't stop there. I mean, you've got the answer, but now go back and answer the question. Okay, you have to break this out, but then interpret what that number means. Okay, so that x, that's how far you can drive on an 8-hour charge. Okay, so, and then yeah, just double check that answer makes sense to you. Yeah, 5 hours is roughly 200 miles. So 8 hours, we're expecting a longer, that you can drive further. So yes, 360, yeah, it makes sense to me. So here's the best answer. So answering the question, you can drive 360 miles on an 8-hour charge. All right, so the new part of this question was just setting these two rates to be equal, but then it's just then you can, once you set it up like this, then you can ignore the miles and hours and just solve the numbers. And yeah, we also see here, yeah, this fraction simplified to 45 over 1. So yeah, that's telling you that if you charge just for 1 hour, yeah, that'll get you 45 miles, and every extra hour is an extra 45 miles of range. Example 2, an hourly worker earns $66 for 4 hours of work. How much do they earn for 7 hours? Yeah, so this, yeah, maybe you're used to this rate yourself. It's dollars per hour. So every hour you work, you get a fixed number of dollars. So this worker earned $66 for 4 hours of work. Okay, so it's dollars per hour. Yeah, it makes sense to put the dollars on the top here, hours on the bottom. How much do they earn for 7 hours? So we have the same rate here. Again, put the hours on the bottom, 7 hours. And we're looking for the x, how much they earn in this case. All right, it's set up now. So now we can solve the proportion with our 3 steps. Step A again, simplify this. Yeah, I think they only have a 2 in common, so cancel 2's. That's 33 over 2 equals x over 7. Set the cross products equal. 33 times 7 equals 2 times x. Yeah, what's that? 231. So 231 is equal to 2 times x. Yeah, this time we do have a number multiplying the x, so divide both sides by that 2. Okay, so if 231 is equal to 2 times x, then 231 divided by 2 is equal to 2x divided by 2. 2x divided by 2, that's just x. So we get to this. And yeah, you could convert this to a mixed number. It's an improper fraction. Here I've done it as a decimal since we're dealing with money. So 231 divided by 2, you get 115, remainder 1. So add a decimal point and a 0 to go one more step. 2 goes into 10 5 times, remainder 0. So this is the exact answer. Yeah, this is x is measured in dollars, so this is $115.5 or 50 cents. So this worker earns $115.50 for 7 hours of work. Again, we're answering the question. Yeah, you lose points if you just leave it like this, or even just this number. For these, for these word problems, you really have to go back and answer the question. Just saying what x is doesn't work because there's no x in the question. Make sure you answer what they're looking for. And yeah, does this make sense? So $66 for 4 hours. I mean, you can see right away if they work for twice as much for 8 hours, that's 2 times this. So $132. So this answer makes sense. Yeah, it's less than 8 hours of work, but not too far away. And again, yeah, the key step for setting this up was to set the two rates to be equal. The dollar, this person's getting paid the same rate each time, number of dollars per hour. So this is the correct way to set it up. The kind of a common mistake is, well, the only mistake you can really make here is to put it the wrong way around. So if you have dollars per hour, it has to be dollars per hour on both sides. Okay, so this one's upside down. So I'm going to cross that out. So don't do that. Okay, another example looks different, but really the same. On a map, 3/4 of an inch represents 14 miles. All right, so yeah, do people still use paper maps? So this map has a scale. So yeah, every map has a scale. Distance on the map represents a certain distance in real life. So here the scale is 3/4 of an inch representing 14 miles. If two cities are 42 miles apart in the real world, how far apart are they on this map? All right, so we're just converting these two sentences into two rates. So for the first sentence, we're comparing 14 miles in the real world with 3/4 of an inch on the map. In the second sentence, yeah, it's the same map, so the same scale. These are equal. 42 miles in the real world. How does that compare with inches on the map? Okay, so we're looking for how many inches they're apart, so that's the x. Okay, so again, that's the hard part of this question, just setting those two rates equal. But it's not too hard. You could have done this with inches on top and miles on the bottom, but just make sure you do the same thing on both sides. So if you have 3/4 of an inch over 14 miles, then it would have to be x inches over 42 miles on this side. That'll work too, as long as they match. Okay, here we have a fraction. Yeah, you can have fractions and decimals, mixed numbers in these rates. We can handle that, right? So, all right, so yeah, we can't really simplify here, but so just set the cross products equal. So 14x is equal to 3/4 times 42. Okay, we're multiplying a fraction by a whole number, so that's 3/4 times 42 over 1. Yeah, you can cancel 2's here, so that's the same as 3 times 21 over 2. And we're getting 63 over 2. Okay, yeah, it's the same as 126 over 4, and then canceling the 2's. Okay, so we get this equation. Yeah, again, we'll be studying these equations in chapter 6. So 14 times the number we're looking for, 14 times x, is equal to this fraction, 63 over 2. I want to divide both sides by 14. Yeah, a nice way to do that here, since we have a fraction on the right, so dividing by 14 is the same as multiplying by 1 over 14, the reciprocal. Okay, so dividing by 14 is the same as multiplying by 1 over 14. We've seen that. So yeah, so a nice way to do this is to, on the right side, it's 63 over 2 times 1 over 14. Okay, you can see the 14's on the bottom, so we're really dividing. And then just to make it easier, yeah, the 63 is 7 times 9. 14 is 7 times 2. So those 7's cancel. Okay, I mean, yeah, you could do, it's 63 over 28. But then to simplify that, cancel 7's. Either way, it's 9 over 4. Maybe it's more useful as a mixed number here, so 4 goes into 9 2 times, remainder 1. So as a mixed number, it's 2 1/4. And let's remind ourselves what the question was. Yeah, so this x, it's x inches, and it's how far apart these two cities look on the map. So the cities are 2 1/4 inches apart on the map. Does that make sense? Yeah, so 3/4 of an inch represents 14 miles. Yeah, so 1 inch would represent about maybe 20 miles. 2 inches would be about 40 miles. So yeah, this makes sense. Right, yeah, in the book, more rates. So yeah, here's a car using gas. Maya used 5 gallons of gas to drive 150 miles. How many gallons will she need to drive 225 miles? So here, yeah, instead of miles per hour of charge, now it's just miles per gallon. We're more used to. So the first sentence, the first trip is 150 miles divided by 5 gallons. The second sentence, the second trip, it's miles, so miles over gallons, so it has to be miles over gallons here. In the second trip, it's 225 miles, and we're looking for the gallons. Simplifying the left side, to cancel 5, so this is, yeah, 30 over 1. And so the cross products here are 30 times x equals 1 times 225. Divide both sides by 30 to get 1x. And then doing this division, yeah, 30 goes into 225 7 times. That's 210. And 15 left over. So it's 7 and 15 over 30. And that 15 over 30 is 1 over 2. So here's the answer. She will need 7.5 gallons of gas to drive 225 miles. Yeah, this definitely makes sense. So 5 gallons gets her 150 miles. So half of this 2.5 gallons gets 75 miles, and then add those together. Yep. And yeah, just as we did before, yeah, this rate simplifies to 30 miles per 1 gallon. Okay, so that's how well her car does. Yeah, it gets 30 miles per gallon. And yeah, more examples here. How about this one? A painting crew can paint 3 apartments in a week. If a building contains 40 equal size apartments, how long will it take the crew to paint all the apartments? So what's the rate here? Well, it's apartments painted per time in weeks. Okay, so the first sentence gives us the rate, 3 apartments per week. Okay, so that's this rate, 3 apartments over 1 week. The second sentence gives us another rate. This time we have 40 apartments, and we're looking for the number of weeks. Using y here. Yeah, any letter will do. So it's 40 apartments in y weeks. Okay, and these two are supposed to be equal. This painting crew works at a constant rate. Three y is equal to 1 times 40. Divide both sides by 3, so y is 40 over 3. 3 goes into 40 13 times, that's 39, remainder 1. So that's a mixed number, that's 13 1/3 weeks. So that's how long the painting crew takes to paint 40 of these apartments. Yeah, they can do three apartments in 1 week. So one apartment takes 1/3 of a week. 40 apartments takes 40 thirds of a week. 40 times 1 over 3. Yep, 13 1/3. All right, yeah. So all the questions we've been doing recently, they all come down to solving proportions like this. Okay, we've looked at percent problems. So A over B equals P over 100. We've just looked at rate problems. There's one more place where these proportions naturally show up. That's similar triangle problems. Okay, so some triangle geometry. Let's look at that next. And so what does it mean for two triangles to be similar? Okay, so here similar has a technical mathematical meaning. Two triangles are similar. Well, roughly it means they have exactly the same shape. Yeah, one triangle could be bigger than the other, but we want the shape to be the same. And so these two triangles, I've tried to draw them the same shape. So this triangle with corners ABC, this bigger triangle with corners DEF, and you can see they're the same shape. Yeah, I've drawn the second triangle. It's twice as big as the first. Yeah, so that the height here is 2, the base is 3. Here the height is 4 and the base is 6. This angle here is supposed to be a right angle, 90 degrees, and the same here. Okay, so these are two similar triangles. They have the same shape. Okay, now there's a correspondence here that we can match things up. So this corner A matches this corner D. The B and the E match, and the C and the F match. Okay, so we're just matching up these, what corresponds to what on these two similar triangles. Okay, so we can match the corners. We can also match the sides. So this side AB matches this side DE. Okay, and yeah, it's the same thing really. So A matches with D and B matches with E. So AB matches with DE. The two bases match, and this is a right angle triangle. The two hypotenuses, the two longest sides match. All right, so when you have two similar triangles, you can match up the corners and the sides. So yeah, so here's the real definition. So two triangles are similar if the corresponding angles are equal. So in our case, matching up these okay, so the angle at B has to equal the angle at E. Yeah, they're both 90 degrees. The angle at A should be the same as the angle at D, maybe about 60 degrees. So maybe use 2 for those to match, and then the angle at C, maybe about 30 degrees, 35 degrees. Well, if this is 35 degrees, the angle at F should be 35 degrees. Okay, so two triangles are similar. Yeah, the real definition is if the angles match, but that's really the same as saying they're the same shape, but maybe one could be bigger than the other. What's this got to do with proportions? Well, here's a fact about similar triangles. So if two triangles are similar with matching angles, then the ratios of corresponding sides are always equal. Okay, so for these two similar triangles, the angle at A equals the angle at D, B, E, the angle at C equals the angle at F. Okay, so we can match up the sides. So this side AB corresponds to this side DE. So make the ratio of the corresponding sides. So we're putting the side from the first triangle on the top, the side from the second triangle on the bottom. So this ratio has to equal the ratio of these two corresponding sides. BC, first triangle on the top, again, second triangle on the bottom. And that ratio is also equal to AC, that length, over DF. Okay, so we're talking about the lengths of these sides. So the length of AB, this number divided by the length of DE is equal to these numbers, these fractions. All right, and yeah, I hope this makes sense. So suppose the first triangle was, say, 2/3 the size of the second triangle. Then all these ratios, they'd all be 2/3. So this common ratio, this common fraction, it's just really the ratio of the size of the first to the second. Example 1. For these similar triangles, find x. Okay, so we have two similar triangles here. We're told they're really the same, just this one is bigger. And from the picture, we can match up the corresponding sides. So this side on the first triangle corresponds to this side on the second triangle. And the two bases correspond. Okay, so using this idea, so the ratios of corresponding sides, so we have these two corresponding sides, 12 over 18 is equal to the ratio of these two corresponding sides, 20 over x. And yeah, just like with the rates, yeah, really the only way to mess this up is to have something upside down. So just remember, yeah, when you're doing this, it's put the numbers from the first triangle on top. That's a good way to keep it straight. Numbers from the first triangle on top, corresponding numbers from the second triangle on the bottom. And so we get this proportion to solve. Cancel sixes. 2/3 equals 20 over x. 2x equals 3 times 20. 2x equals 60. So x equals 30. And yeah, take a look that number makes sense. Yeah, it's certainly expecting something bigger than 20. And here, yeah, the question was just to find x, so x equals 30. That's what the question was looking for. All right, so I hope that made sense. So when you have two similar triangles, the idea is that the lengths of corresponding sides, the ratios of those lengths, always give you the same fraction, the same ratio. And we're always putting the numbers from the first triangle on top, the numbers from the second triangle on the bottom. And to make a fraction, you have to use corresponding sides. And so here, AC, that side corresponds to DF. So we make the fraction AC over DF. Example 2, two more similar triangles. This time we're looking for the length of this side, y. Okay, so the sides here are 12, 7, and 10. Here we just have a 17 and a y. Okay, so maybe try, see if you can set this one up. So what is the proportion that we're starting with? All right, so let's take a look. Okay, so yeah, we can see what corresponds to what. So this side of length 12, that corresponds to this side of length 17. Okay, so we get the ratio of 12 over 17. First triangle over the second triangle. And the 7 and the y correspond. So we get 7 over y for the second fraction. And yeah, here we didn't need the 10. Yeah, there's no number here. And so this base corresponds to this base, but since we're missing this number, yeah, we didn't need that 10. Okay, so I hope you got this this proportion. We need to solve 12y is equal to 17 times 7, 119, and then divide both sides by 12. 12 goes into 1199 times. That's the best you can do. That's 108. Remainder 11. So, yeah, it usually makes sense to convert these improper fractions to mixed numbers to get to see how big they are. This is 9 and 11 twelfths. Yeah, we're certainly expecting a number bigger than 7. Since this triangle is bigger, 9 and 11 twelfths, yeah, close to 10. Looks good. Okay, one more example from the book. Yeah, so yeah, here's another example of two similar triangles. Yeah, the angles are the same, so these triangles are similar. And yeah, here's the same rule. Corresponding sides of similar triangles are proportional. Okay, let's look at this one. So these two similar triangles. And we can see, again, that here A corresponds to D, B to E, and C to F. Okay, so these angles match. This angle is the same as this angle. This angle is the same as this angle. And these. Okay, so these are similar triangles, so we can match up the sides. So here we could do 15 divided by 22.5 has to equal 12 divided by x. So that's putting the first triangle on top. Yeah, here they put the second triangle on top. As long as you do it consistently, that's okay. So here we have so 22.5 divided by 15 is equal to x divided by 12. All right, so the second triangle on top here. And we get this proportion. Solve this. 22.5 times 12, that's 270. And on the other side, it's 15x. Divide both sides by 15. 15 goes into 270 18 times. So the missing number here is 18. X equals 18. certainly x should be bigger than 12. Since this triangle is bigger, yeah, so x equals 18. Oh yeah, there were units here, so the units here are feet. You know, I like to take points off if you don't include the units. So here, 18 feet.